And we are live. Welcome everybody for this live stream. Today we are going to code a crypto wallet. This is going to be a step-by-step coding tutorial. If you are a complete beginner in crypto and you've never tried Web3 development, that's okay because we're going to take it one step at a time. All right, so if you are new to the channel, I'm Julian. And if you want to know how you can start your career of Web3 developer, check out my free blockchain developer roadmap. That's basically a career guide that covers everything that you need to know before you get started in this career. So it will tell you exactly what you need to learn and how to get your first job in the space. So check it out. It's 100% free and it's going to save you a lot of time. eattheblocks.com/roadmap. All right, so we got some people in the chat already. We got Mehmet, we got Vlad. Let me know where you guys are from, and I hope that you guys are excited for today's tutorial because it's going to be a great, what we're going to build today is going to be a great project for your portfolio. So here is basically what we will build today. It will look like this. So you'll have a nicely polished wallet, and with this wallet it can show you your balance in Ether. It can show you your balance in different ERC20 token, and you can also do a transfer here. So you can select the asset, the recipient, the amount. Here you can specify an amount. You click on send, you click on submit, and it's going to send the transaction and give you a link to Etherscan. So it's pretty neat. It looks simple like this, but the user experience is polished. I spent some time on this, and you will see that the code is not as simple as what you think. All right. And this is a great project for a portfolio. And of course, you can go beyond that. And I will let you know at the end of this stream how you can make it even better. All right. So first of all, let's talk of what is a wallet. So a wallet is a critical piece of the infrastructure in a blockchain application. So this is where users will put their private key, which is the equivalent of a password, but for crypto. And with this wallet, what user will be able to do is to sign what is called a transaction. And a transaction is how a user specify what kind of action they want to take on the blockchain. So if you use a blockchain app, and let's say you want to do some action like make a transfer of money or anything else, then what you will need to do for that is a signed transaction. And to create this signed transaction, you will need a wallet. And one of the most famous wallet is called Metamask, and very concretely, that is a browser extension. So you go on the Google Chrome and you can install it. You also have wallets that are mobile apps, and you also have wallets that are desktop app. Okay, so three kind of packaging, either desktop app, mobile app, or Google Chrome extension. And the vast majority of users use MetaMask, the Google extension version. So for this tutorial, I wanted to focus really on the blockchain part. And the problem is if we do a Chrome extension or a desktop app or a mobile app, it's going to take a lot of the focus away from the blockchain. So that's why in order to simplify, we are going to do a web app. So with a backend and a front end, but I will explain how you can repackage this in a desktop app, mobile app, or Google Chrome extension at the end. You don't need to make a lot of changes. All right, so let me show you this schema, which is basically an explanation of how the wallet is going to work. Okay, so this is going to be a web application. So we're going to have some JavaScript code. We're going to read a configuration file where we're going to specify our wallet, which asset we want to track, because there are different kind of assets on the blockchain. Basically, there are two broad categories. There is the native asset, which is the a special asset in each blockchain. For example, for Ethereum, the native asset is Ether. For the native asset of the Binance chain is the BNB coin, etc. Each chain has their native asset, and then we have all the ERC20 tokens. For example, DAI is an example. USDC, USDC, USDT. All your meme coin usually are ERC20 token. And so our wallet will be able to handle these two kind of assets. So we'll be able to do to see our balances in those assets and do transfer. What we will not be able to do is to interact with a decentralized application. So that's the finally next level. But for this tutorial, it was a little bit outside of the scope. And so we're going to read the asset from this configuration file. We're also going to have a private key that our JavaScript code is going to read. And with this, we will be able to connect to the blockchain through the API of the blockchain. So we'll be able to get the balance of Ether, and we'll also be able to get the balance of the different token that we are tracking. But to know which token we are tracking, first we need to put everything in the configuration file, because otherwise the wallet cannot guess what are your assets. And finally, our JavaScript code is going to interact with the CoinGecko API. So CoinGecko is a website that gives you the price of different cryptocurrencies, and they have an API, and we're going to need their API for our wallet. All right. All right. Let me see what we have in the chat. Why are you guys so obsessed with ETH? ETH is absolute trash network. Okay, so this is typically the kind of discussion that is very unproductive, and a lot of people are completely missing the point. You know, like, this blockchain is better. No. This is not how it works. You have a blockchain, Ethereum, where you have most of the job market, most of the builder out there. So this is where you have to be as a builder. If you don't care about your career at all, yeah, you can waste your time and you can comment and why such or such blockchain is better, but you're not gonna do much with your blockchain career if you do this. Okay, so this is not even sort of choice you have to question. It's just obvious the vast majority of developer needs to be on Ethereum. All right, so let's move on to more productive discussion. So here, the technology we're going to use is JavaScript to create our front-end application. Then we're going to use HTML, CSS, and to make it nicer, we're going to use Bootstrap. All right, we're going to use Next.js also, which is a framework on top of React to easily make dynamic applications. To interact with the blockchain, we're going to use a JavaScript library called Ethers. We're going to connect to the Ethereum blockchain. So our wallets can not only work with Ethereum, but can also work with any EVM compatible blockchain, which are the majority of blockchain out there. We are also going to use a smart contract framework called Foundry. This is going to be very useful in order to test our wallet, because we will be able to use the local development network of Foundry and deploy some mock tokens. And finally, we'll use the API of CoinGecko to get the price of Ether that will be useful for our wallet. All right, and at the end, this is what we're gonna get. Okay, so let's start the coding. Okay, just give me 1 second. All right, so here we go. Okay, so I've started a new Next.js project. So in order to do that, you need to have Nodejs installed, of course, and then you run npx create next app dot, and it's going to create a new Next.js project. in the folder. So here you can see all of this except blockchain here. All of this is the Next.js basic project, and I already have some basic code, so to save a little bit of time, because not everything is super interesting when we set up a new project. So I already have some basic CSS here to have some basic styling. It's the same base I use for most of my project, basically. I've also customized the layout file where you can set up CSS. So here I imported the CSS of Bootstrap. A Bootstrap icon is to get some nice icons. So I had to install this npm install Bootstrap and Bootstrap icons. Also had to install ethers. All right. Here we import our own global style sheet. Here just some title to customize to customize our app. Here we are loading some font from some Google font, and yeah, so that's it for this file. Then for the page.js, so this is gonna be our home page. And here I have some basic HTML, okay, a couple of div with a couple of Bootstrap class in them. Title, subtitle, not the most interesting, but that's the setup. So now if we run npm run dev, we're gonna see something basic. Okay, so let me reinstall this because I've copied this from another folder, so usually npm doesn't like it. So let's run the install again. Okay, so now it should work. So npm run dev. All right, so now you can see that this is running on localhost 3000. So you copy paste this, and on the front end, you can load this. So now you can see some basic app. All right. I also have a .m file, so I'm not going to show you the real one. I just show you the copy because there is some secret in there. But basically, this is where you put some basic configuration as well as your secret. So first of all, we're gonna have a link to our local blockchain network. So this is not the real blockchain, but you could, in a real production scenario, you will put the URL to something like Infura, for example, which is a blockchain API. And here for testing, we're going to use a local blockchain, and I'm going to show you after how to start this. Mnemonic, this is basically this is a secret that allow you to generate all the addresses for your local network. So here we all have the same, basically. If you use Foundry, everybody has the same mnemonic, so we don't care. But if that was a real scenario, of course, you want to keep this private. Be very, very careful with it. And here, so the chain ID, this is going to depend on the network that you target. So this is the chain ID for local host, but there are other chain ID for all the network, and you can see this on chain, let me see, chainlist.org. Here, for example, for mainnet, Ethereum mainnet, the real production network, this chain ID is 1. Okay. Then we have the CoinGecko API key. Okay, so as I mentioned, CoinGecko, this is this website that gives you, so the basic version of CoinGecko, it's a little bit like a CoinMarketCap. So it gives you a list of all the crypto with their prices, but it also has an API so that you can access those prices through your code. And they have a free API. Now they really highlight the paid API here, the professional API. So if you create an account, it looks like there is no free API, but it does exist. It does exist, and when you create it by email, it's going to send you your API key. All right. And you have access to a couple of endpoints, and the one we want is a simple endpoint that gives you the price of any crypto here. So very simple. And you need to prefix all of this secret by next public so that we can read those variables in the front end. So in this case, this is just an app that we are doing locally as a tutorial. So you don't care that it goes on the front end, but in a if it was a production application, that would be more problematic, especially for your mnemonic. All right, but here, just to simplify, we're just gonna make everything accessible to the front end. All right, so let's get started with on page.js because we have some work to do. So what we need to do is first we need to connect to the blockchain. Okay, so for that we will need a special function called use effect. This is run by Nodejs when you upload for the first time. So we need to import it first. So let's do this: import use effect from. So even though we are using Nodejs, actually use effects come from React. Okay, so when you install Nodejs, it also installs React. So we use effect. All right, and now what we're gonna do is we also need to use a state because basically we're gonna have what we call a provider. So provider, this is an object that allow you to connect to the blockchain. We're going to see how we can create one. Here we use another special function of React called use state that will allow you to define an initial an internal state in your component. So use use state here. Okay, and the other state that we need is wallet. So this is an object that allows to send a signed transaction by reading our private key. Okay, so all right. Then in the use effect hook, now what we're gonna do is so this is going to run when the component load for the first time. And if we don't have a wallet yet, we are going to create it. By the way, we are missing an empty array here. So this weird notation use effect with the empty array means that it's just going to run at the beginning when the component load for the first time. So let's create the provider object. And for that, we're going to need a JSON RPC provider. So that's an object from Ethers, okay? The JavaScript library to interact with Ethereum. And with this, we pass the URL to our Ethereum node. So process next process.env.next public, and I forgot the name, so let's check out here. Is this name right? So next public local RPC URL. All right, so we have our object to interact with the blockchain. All right, so next we need the wallet object. So the wallet object, we're gonna get it from another object of Ethers called wallet. So let's import it. All right, and after that, we're gonna use a method called from phrase that allow you to create a wallet from what we call a mnemonic. So the mnemonic is the secret I showed you before, process.env. So next public mnemonic. All right, and then we pass the provider object that we created just before. So next public mnemonic, let's see it again, is this thing, test, and then this will be given to you by your, so when you create a new private key, basically it will be associated to a mnemonic. And okay, so with this wallet object, we can send transaction. And so now let's save these in the state. So, okay. Now the next thing that we need to do is to we need to check if the wallet is loading. Okay, so for that, here, let's check that. Do we have a wallet? So if yes, wallet loaded. And if that is not the case, then we're just gonna display loading. All right. So let's go to the front end. Okay, so now we see loading. And so actually it's weird that it showed me wallet loaded because I haven't started my node yet. So we're gonna do it. Let's open a new tab. Okay, and in this new tab, we are going to start our local blockchain. So I already have installed the Foundry framework that I showed you before. So this is this thing. If you don't have it installed, you go to installation here and you follow the instruction. That's very easy to install. And once you have installed it, you have access to an executable that is called Forge. That's called Anvil. Sorry, and Anvil is a local blockchain basically that you can use for development. So you just have to type Anvil, enter, and it's going to start a blockchain. All right, and here you're going to see it generate some 10 addresses, each pre-funded with a lot of Ethereum. So this is not real Ethereum. This is only valid on this local blockchain. Each of these addresses is associated to a private key. And you can see the mnemonic here that was used to generate all those addresses, all those private keys. You can see your chain ID. And now it's listening and you can use it. Okay, so we're going to connect to this. Okay, so now we have our wallet and provider loaded. So the next thing that we're gonna do is we're gonna show the balance of Ether of our address. Okay, so let's do this here. Let's we're gonna call this part overview. We're gonna define a style sheet for it. Okay, so for our style sheet, this is going to be a new, let me see, new file, page.module.css. So this is how you add CSS in Next.js. And so let's define our overview class. All right, let's give it a background color. It's going to be slightly gray. Border radius, some rounded corner, some padding. We're going to make everything centered. And let's give it some margin. All right, and then we're gonna, so let's close this. Let's import this. Import styles from page module.css. All right, styles in here. All right, so after inside, first let's show the our address. All right, so we're gonna do the styling just after, but Let's do wallet address. Okay, because this in the wallet object, we have access to this address field. And another paragraph, this is going to be for the balance. So for that, okay, so balance will be here. But first, let's see that we see our wallet. So wallet, yes, 0xF39. And if we go back, if we go to envol, we can see that this is correct, 0xF39. So this is correct data. Okay, so let's style this. Let me see. We're going to style the address. So let's go here, address, and all we need for this is a special font family that looks a little bit like if it's that make it look different. So this font usually is good for that. All right, let's see. Let's give it a class name. All right, so yeah, now this is slightly better. Now we need the balance. So how are we going to do this? We're going to use another use effect, okay? And with this other use effect, we're gonna load the balance of Ether. So we are going to wait that the wallet object is loaded, okay? This is why we see the wallet here in this array. And if when the wallet is loaded, then we're gonna trigger an internal function. So why we're doing an internal function here, we don't put the code directly there. It's because we need an async function, because inside we're going to use the await keyword to do a HTTP call. But to use await keyword, you need an async function, and you cannot have an async callback here and use effect. Don't ask me why, but it's just like this. React is not going to like it. So now let's have our balance here. So balance, this is going to be await provider, and then using get balance. There is an API call just for that, and we just needed to give it the address of the wallet. All right, and after that, we can, for example, create an internal state called balance. All right. So, yeah. All right. And now let me see, is there no error? Okay, and now let's load the balance here. So all right, so let's see. Right, so we don't have a balance, so that is not normal. So why we don't have a balance? Well, maybe because that is not a number, but that is a big int. So that's a special class of number in JavaScript, which is represented by an object, and we need explicitly to call toString to see it as a string. Okay, so now we can see it. All right, and so this should be 10,000 Ether, and to make sure of this, we can do is multiply it by 10 power minus 18, because the balance you're going to get from the network is not in ether directly, but that is in an elementary unit called Wei. 1 Wei equal 10 power minus 18 in ether. So that's a very small fraction of an ether. So if you want to convert this to an ether, we need to do this multiplication. And here we can see 10,000, and that matches what we have with Envil. Let me see. Here 0xF39, and you can see we have 10,000 ether balance. And by the way, you can follow the interaction with the blockchain here in this terminal, because it tells you all the calls that are made to the blockchain. So here, for example, we can see that we call ETH underscore get balance, and that's normal because we call it here. Okay, so everything makes sense. All right, so you know what? It's a bit ugly. Okay, our balance like this is a bit ugly. It's not really user friendly because users don't really deal with Wei. They deal with ether. So we need to make it look nicer. So we're going to do this with CSS, but also with code. Okay, so let's start with code. So here, let's give it a class name of stars.balance. Okay, and after, let's do it here. So balance, let's give it a font size of 2 EM, so make it a little bit bigger, and the font weight, it's gonna be bold. All right, so now should be better. Let me see. Yes, so 10,000. All right, ETH. So let's put here ETH, but it's actually not true, because in order to have it in ETH, we need to change. We need to change the scale here. We need to make a division. So we are going to create a function for that, because we're going to need to do this operation several times. So we are going to create a new file called utils, and inside, let's create a function to format those amounts. Format Wei amount. It's going to take the amount to format and the number of decimal. So decimal, you know, I told you that 1 Wei equal 10 power minus 18 ether. So decimal, this is this number here. This is what you have at the exponent. And let's do this. So we are going to use a function of ether called format unit, right? So import format units from ethers. Okay, and it expects first the amount and then the number of decimals. And we could just return like this. Okay, so that would be a first improvement. So let's import format Wei amount from utils. We can remove this in this case, and the number of decimal is going to be 18. Okay, so now you can see that it's slightly better, so 10,000 ETH, but still it's not ideal because we have this trailing 0, so we want to get rid of this. This number is useless, and also it would be nice to have some comma separator for the thousands. So you might say, hey, like who cares? We just want to do blockchain stuff. But yeah, you see, if this is a wallet, it needs to have a good user experience. Okay, so you need to care about this kind of detail. So let's revisit our formatting function, and we're gonna make it a little bit better. We're gonna use another function to add the 1000 comma separator. So here we're gonna return an object international dot number format. That's a JavaScript function to add the comma separator. So first you need to specify the local. So let's make it easy. Let's specify it's the US, okay? And then for the number of maximum fraction digits, this is gonna be the number of decimals of this asset, okay? And then we call the format function. We pass it the amount, and that's it. And now if we go back to the front end, now you can see it's pretty nice. We have our comma separator. So yeah, we are making some progress, all right? But let's make it a little bit nicer. And now what we want is to add a logo, okay? So just above, let's create a paragraph. And here we are going to add the logo of Ethereum, okay? So here we're going to do this. All right, so here we have a couple of things to create. So we need to create this variable native asset, okay? And we also need to create this component logo. So let's do this. And for that, so we're gonna create new state that we're going to call native asset set native asset, right? And we're gonna give it an initial native asset initial. Right, and so how are we going to find this? How are we going to populate this object initial native asset? Well, we are going to take a step back and check out our configuration file blockchain.json. So this is a configuration file that I've created, and here our first key in this file is assets. So that's a list of assets that can be managed by our wallet. So here, for example, you have a testnet ether. For each of these assets, I gave them an ID, just arbitrary ID. Here, this is the ID that is used by CoinGecko to get their price. Here is their ticker, so an abbreviation that we use for the front end. Here, the number of decimal. Here, the logo. So basically, that's up to you to find the logo for each asset, and you need to put them in public. And here I've created this folder assets, and then we have different logo here: DAI, ETH, USDT, etc. All right. And finally, chain ID. So this each asset is defined per chain. Okay. So here we have testnet for local blockchain. Here we have tether for the local blockchain, etc. And here, for example, we have ether that is redefined a second time, but this time this is for mainnet, etc. for each asset. And then I have another key here where I have an array of the different chains that are managed by this wallet. So first we have Ethereum testnet with the chain ID. So what is the native asset ID here is 0, and an URL to the blockchain explorer. So yes, it takes some work to create this configuration file, but it makes the front-end code way more easy and way more simple. And also it makes your wallet way more configurable, because now if you want to support more chain or you want to support more asset, you just have to add some entries in your configuration file. Okay, so that's very flexible. So we're gonna import this file. Let's import blockchain from blockchain.json. Okay, and first let's define an initial chain. So blockchain.chains, and we're just going to take the first element of the array, which is the local development blockchain. And then for our initial native asset, we're going to just take the first asset of this chain. So blockchain assets and find, this is going to return the first element that matches a criteria. So asset, we want the asset ID to match initial chain native asset ID. Okay. So now native asset is going to be populated, and we gonna be able to read it here. So yeah, native asset dot name. Sorry, I forgot that. Okay, so now let's create this logo element. So let's create a new folder that we call component, because we're going to reuse this at several places. Inside, let's create logo.js. Okay, then so we're gonna import the image component from next image. Let's export our component. All right, and let's directly return the image, and we define a few property. So we want some space on the right. So with Bootstrap, if you want to add some space above, it's margin top. At the bottom, it's margin bottom. But on the right, it's not margin right, it's margin end. And on the left is margin start. Okay, so it's not super intuitive for right and left. All right, then for the source, so we're gonna read the asset object, and this is gonna be the logo. Then alt is just to avoid some warning in the console. Then let's define the width, so 20 something for the height. Okay, so now we have our simple logo component, and now let's import it. So import logo from component logo.js. All right, how you guys doing in the chat? Okay, I saw some strong discussion before, like pro against Ethereum. All right, I see a few regular here. I see THX. All right, let me see if there's any questions. So, in addition, will we use Solidity for this project, sir? We will use it, but it's just for testing, just for a small part. What else? Some people are discussing if they should get into Bitcoin. No, Bitcoin is good for speculation, but that's it. That's it. For blockchain dev, there isn't much. Okay, so now let's display our logo. Okay, it's here already. So let's go to the front end. And what's your problem, my friend? Invalid big number-ish value. Okay. So our friend is not happy. Let me see why. So let's try again to add toString. Maybe that will fix the problem. Cannot. Okay, I think I know why. Sorry. I messed up. Shouldn't have remove that. Logo.js. Okay, so back here, yeah, we have a little problem here, so we need to make sure that the balance exists first, because otherwise if we pass a zero value, it's going to okay, now this is working. So we have our balance, we have our address, And we have our network with a nice logo. Very cool. So next, what we need to do is, let's see the finished product here. So the token, we're gonna skip it for now, and we're gonna focus just on this, which is basically the transfer module, where you specify how much you want to transfer. So we need to create a form with different field, a field for the transfer asset, a field for the recipient address, and a field for the transfer amount. Okay, so let's do this. Let's remove these things while it loaded. And instead of that, we're gonna have the transfer div. All right, so styles dot transfer. Let's give it some style. So for the background color, this is gonna be okay. All of this is gonna be the same. Let me see. Background same, padding, yes, and that's it. That's all we need for the style. Now inside, we're gonna have a form with different element. So first group, it's going to be the asset selection. So let's have a label, transfer asset, okay, and input of type text. Then class name. So those class names are coming from Bootstrap. Okay, so when Bootstrap provides some basic styling, I use it. Otherwise, I customizing with my own page.module.css. Placeholder, so if we don't put anything, we're gonna put ETH. Basically, you need to choose one of the tickers that we define in our configuration file. The name of this is going to be asset. Okay, the value is going to be, so here we are going to define a transfer object. Okay, and in this transfer object, we're going to put the asset that we want to transfer, and that include a subkey called ticker. Okay, and then we also need to define a function to handle the input change. Okay, so let me see. All right, so let's define this function above, handle input change, and in this function, so we're gonna receive an event object. Okay, and let's destructor the name of the field and the value. Okay, name, value from the object, the event target. And depending on which field is updated, the treatment will be a little bit different. Okay, so if the name is if the asset, then basically what we are going to do is the value. Let me see how we're going to do this. So we're gonna have a list of assets. Okay, right now we just have the native asset. Okay, And in this list, we're gonna need to find the right one. Okay, so asset ticker, the one that matches with the ticker. Okay. And actually, we might not have a match. Okay, so if we type ETH, for example, we will have a match. But if we are typing the wrong thing, or if we haven't finished typing, let's say we just type E, but at this time we don't have TH, so we're not gonna have any match. In this case, we're just going to put an object with the ticker without any modification. So here, let's save the ticker from the value. Okay. And after that, we set the transfer. So we're gonna define this state just after. And here, what we're gonna do is so we're gonna put the previous value of transfer, and we're going to overwrite this key, the key that we are updating. So maybe it sounds a little bit complicated just for this, but actually we were going to use the same function for all the fields. So that's why here we do something a bit generic. And now we need to define the transfer state. So set transfer, use state, and let's define an initial transfer. All right, so So 2 is good. We're gonna choose the second address of envol. It's just to make it easier for testing so that we have some data to work with. We don't need to type every time. Amount, just 1 Ether, for example. And for the asset, initial native asset. But you're gonna be able to change that, of course. Okay. So let's go back here. All right. So now let's see what we have in the front end. Okay. So here it seems to be working. Okay. Then back here. So let's put the other field. So let me see. So then we need some other field. So let's copy paste this. The next field we need is the recipient address. So transfer to. Let's put here 2. Let's put an example address here. So 0xu, etc. The value of this is going to be transfer.to. Right? On change, we're going to call the same function. And it is going to be disabled if we don't have the transfer asset ID, and this situation will happen if we try to select an asset that does not exist, or if we are still typing. Okay, so let me show you. So here, for example, yeah, it's disabled because we don't have any transfer assets. But now if we type ETH, now that matches an asset we have. Okay, if we type ETH plus something else, now it becomes disabled again. Okay, so you can see the behavior. Now on the handle input change, so this is not going to require any special treatment. So what we did will work just fine. Then we need we need to specify the amount that is transferred. Okay, so let's do this. Transfer amount. And here the placeholders 1, for example. Amount. Value transfer amount. And on change, so we're going to need to modify this function, and the disable rule is still the same. All right, so now, so handle input change. So you are going to, so first of all, we're going to do a formatting here. We're going to create a new function to format it, to add comma separator. Format transfer amount. So we won't be able to use the function we already defined before in utils.js, because here basically we will not convert it from way to non-way. It will always be in whole unit, okay? Because the users, they never talk in terms of way. I will say, for example, let me transfer 1 Ether, let me transfer 1 USDT, but I won't tell you I want to transfer 1 million way of Ether of USDT. Okay, so in the value that we're gonna have here, it's always the whole amount, but we need to add the comma separator. So let's define this function. All right, so what we could, so here we can copy paste this part. You will see that actually it's going to be more complicated than this, unfortunately. So the maximum fraction digit here, this is going to depend on the asset. Okay, so we actually need to know what is the asset that is being transferred. All right, so let's see here. So for example, yeah, here 10,000, and now we start to have some problem. Okay, this is because we have a feedback loop where basically our function add a comma, but then we save this in the state, and then so the state pass it to our function again, and then we try to process this number with our formatting function again, but in input it already has a comma, so it's not a valid number. So we just want to display it with a comma, but we don't want to we want to remove the comma before we save it in the state. Okay, so for that we're going to change handle input change, and for that we're going to add an if statement. So if the name equal the asset, then the amount, we're going to clean up the amount. So it's very easy. Replace all by nothing. Okay, and so we should solve already our problem here. Okay, so now we solve the problem, so that's good. But now we have another problem. What if we want to put some how do you say, some decimal? So let's say here I want to do 10 dot something. If I type dot, it actually doesn't register, and that's because with this function, this function, we can only have integer. Okay, but sometimes we don't have integer. So how are we going to do this? Well, we need to do a special case. So for that, let me see. So let's transform this into a number. If this is inferior to 1, so if this is like 0.9, etc., or if this is the last digit of the number, dot, so means we are still typing, and the different so if we have a dot in the number, so that means it's different. If we have a dot in the number, and guess it's getting a little bit complicated here. And the last number of the number is not 1, 1, 2, etc. 1, 2, 3. 5, 6, 7. 9. Include, and now we're going to select the last number, the last digit of the amount. Okay, so if here it means if we have a dot in our numbers, this is not a whole number, it's not an integer, and the last digit is one of these, then basically you don't do any formatting, you just return the amount. Okay. Let me see. So now can we do dot? Yes, now we can do dot. All right, so now it's working. All right, and now it's working. Cool. Okay, perfect. So we are happy. We have so it display like we want. It's nicely for the user. Okay. Next, what we need to do on this, we need to have a button that is going to submit this, that is going to trigger a pop-up. Okay, so let's do this just below. All right, so here let's define a button. Let's give it some class. All right. Then on click, so once we're gonna click here, we're going to show a modal. So that's a pop-up, basically show transfer modal true. So that's a new state that we are going to define. And we also need to disable this button in different cases. So for example, if no asset is selection for transferred, if we are already showing the model, so we shouldn't be able to click here again. And if the detail for the transfer are not complete, so transfer to, transfer amount. Okay, we're gonna call this send. And not just below, if we have show transfer models, that's the state we're going to define. And basically, let's show this new this component. All right, so transfer. It's gonna have a couple of, we're gonna pass it a couple of prop. But first of all, let's define this state on top. Set. And initially this is false. Right? And let's define this new component here. Rename transfer.js. Right, so export default function transfer, and let's just return some some basic stuff. Okay, so we're gonna have an overlay. So that we have a nice effect. Styles. Overlay, okay. And another one called transfer inside. All right, so let's define a new CSS file. So transfer module.css. Let's import it here. Right. Now, in this new CSS file, I'm going to define a couple of things. So, style for transfer and a style for overlay. So overlay, it's going to be below transfer. First, let's define a background color. Sorry, I'm getting confused. So first, now let's overlay. So position is going to be fixed. Top is going to be 0%, left 0%. Height is going to cover the whole viewport, so 100 VH. Same for the width, 100 V width. And for the background, is going to be semi-transparent. It's going to be black, but semi-transparent, 0.6. Okay. And for transfer, so background color, we're going to give it some border. All right, it's going to be some gray and some radius. Then some padding. Then let's also make it fixed. Actually, I think all of this is going to be position, yeah, position fixed. This is going to be the same, but we want to make it at the center of the screen. Okay, so for that, here's the trick we're going to use: the top 50%, left 50%, transform, and here we're going to translate it of -50, -50, right? And the width will be 50%. All right, so we finished with all the boring CSS. So now let me see what we have in the front end. If we click here, the transfer is not defined. Okay, we haven't imported it, so that's normal. Let's go back to page.js. Let's import transfer from components transfer. Right, send. Okay, so seems a little bit messed up, but we have the overlay, but it's just that here it's not at the center. Let me see why it's not at the center. Some problem with our CSS, maybe. Okay. I think here that's because left, this is at 50%, at 5% instead of 50%. Let's try again. Okay, so now it is better. Very cool. Okay, so we need to pass some information to this transfer component. So let's go back to our main component and see what we can give it. So it's gonna need the provider. It's gonna need the wallet. With the provider, we're gonna get the balance. We are able to get the balance in Ether. With the wallet, we can send transaction. It also needs to know what is the current chain. It needs to know what if the native asset, and this is stored in the state. You need to know the transfer object. Okay, and also we're gonna pass it this state, this setter function for the state, because we're gonna have a button to close the module. So we need to update the state of the parent component. Okay, so set show transfer module. Okay, so now let's go to transfer. And let's define the different prop that we get. So we get the provider, we get the wallet, we get the chain, we get the native asset, we get the transfer, and then set show transfer model. Okay. So now what we need to do is first of all, we want to define a button to close everything. Okay, so so when we click on this button, what's going to happen is we're just going to update the state of the parent component. Very simple. And I'm going to call this close. All right. So set. What's your problem? Chain is not defined on the parent component. Okay, why this is not defined? Let me see. We haven't defined this state. Okay, so let's do it. Chain set chain. All right, so now let's click on. Okay, and so now if we click on close, then it's closing. Okay, very good. So next, and we need to show the detail of the transfer. Okay, so first of all, let's just mention that this is the transfer details. Give it some basic styling. All right, and now let's specify what is the current network. Let's give it some breathing room at the bottom. Okay, so input in, no, this is self-closing element. We don't need the other one. Type text, and all of this. So even though we're going to use a form, this is going to be disabled. So we can only read it. We cannot modify anything. True. Okay, so the name of this is network. The value chain.name. So that was defined in our configuration file. And let's see already what we see here. Send. Okay, so Ethereum local testnet. It's working. Now let's add other stuff. So from. Okay, so now we're going to read this from the transfer object. Let me think about it. No, from the wallet. Sorry, wallet.address. Okay, then to, so the recipient. So the recipient here, let's change the name. Recipient, we're going to read it in transfer object. Okay. Then we have the amount. So amount transfer is let me see, amount. We don't need to do any formatting because this is specified in whole unit, not in way. And the last one will be transaction fee. So this one is going to be a little bit more tricky because we need to do some calculation here. All right, so let me see. Transaction fee here. Okay, so we're gonna need to do some calculation. So let's see already if everything is working. Let's click on send. So Ethereum from to amount transaction fee here. Okay, what if we put, I don't know, 10.5? Do we see 10.5? Yes, amount, we see 10.5. Okay, so it looks like it's working, but for the transaction fee, it's definitely going to be a little bit more challenging, but that's okay. We're going to do it one step at a time. So how are we going to do this? Well, we're going to use a use effect function. So let's import it first. And this is going to be triggered when the component first load. Okay, so what do we need to do here? We need to compute the goal. We need to compute transaction cost in Ether and also the transaction cost in US dollar. Okay, so this is why we'll need also the price of Ether to convert Ether in dollar. Now, how are we going to do this estimation? Well, it turns out that we can estimate the gas cost of a transaction with ethers. So first of all, we estimate the gas cost of the transaction. So the gas is a unit that is measured to for transaction fee, but that's an abstract unit. It only tells you the computational difficulty of your transaction, but it doesn't actually give you an ether value. Okay. Then we need to get the gas price parameters. So the gas price, it's a parameter that tells you that you specify when you set a transaction, you decide the gas price, and it allows you to specify how much you want to pay miner for a specific gas cost. Okay, so let's say your gas cost is, I don't know, 10,000 gas. Okay, if your gas price is high, well, maybe that you're gonna pay your miner, I don't know, 0.1 ETH for the transaction. But if your gas price is low, then maybe the miner is only going to receive much 0.0001 ETH. Okay, so you have to choose the gas price wisely so that it's high enough for the miner to be interesting, but not too high so that you don't overpay. And we will see how we can estimate those gas parameter. Then once we have this, we compute transaction cost in ETH. Okay, because now we have the gas cost of the transaction plus the gas price parameter, so we can get the transaction cost, and finally compute transaction cost USD. By using the current price of Ether, we can convert this quantity into USD. Okay, so this is what we're going to do. So first, let's start with estimating the gas cost. Okay, so let's define a function. All right, let's call this function here. Let's first estimate the gas cost. So let's define a transaction request parameter object, where specify a few details about this transaction. So what is going to be the sender, what is going to be the recipient, and what is going to be the value. Okay, so you cannot put the transfer amount because this is an amount in whole unit, but we need the amount in way because the Ethereum network only understands way, doesn't understand whole unit. So for that, to transfer whole unit to way, we use a function of ethers called pass unit. And pass unit, so we need to import it first. Import pass units from ethers. Okay, and after that, let's specify how many decimals we have. So that is something that we have on the transfer object, and all of this comes from initially from our configuration file. Blockchain.json here. If you remember, we defined a number of decimals for each asset. Okay, so here we have the number of ether that we're going to send. Okay, and now we're gonna do wallet dot estimate gas estimate gas, and we pass the transaction request. All right. All right. So next we need the gas price parameter. So the gas price parameter, I'm going to simplify it for you because there was two versions for transaction. So there was the old transaction type 1 with just the gas price. So this was a little bit more simple. And then there's a new type of transaction type 2, which is related to EIP 1559. So before you just needed to estimate this parameter, the gas price, and that was it. But now, basically, there are two, the gas price has been subdivided in two parts. So you have basically a base fee that is going to be paid to the Ethereum network. And then you're going to have what is the name of this other fee? The fee, let me see, base fee, and the other one is, I think it's miner tip. Basically, this is what you're going to give to the miner. So the base fee is given by the network. Okay, so at any time, the network will tell you what is the base fee, and the miner tip. This is up to you to decide it, but fortunately, we can use an API to help us with this. So we're going to use provider. So this is basically ethers, and it has a function called get fee data, and it's going to give you all the gas price parameter. So and in this fee data, it's going to have different information, but the one we want is max fee per gas, and that include the base fee and the miner tip. Okay, and that's the most simple is to use this. If you want to be more granular, there are other ways where you can decide the miner tip independently, but the most simple is just to take this estimation. So this is what we're going to do. All right, so we have the max fee per gas in fee data, and then so now we need to compute the transaction cost in Ether. Okay, so in order to do this, ETH gas cost time fee data max fee per gas, but we need to make sure that everything is as a big int, because this can be very big number that go beyond the limit of number in JavaScript. Okay, so let's wrap everything by a big int. This is provided by JavaScript, big int. Okay, so now we have our transaction cost in ETH. And what about the transaction cost in US dollar? So for that, we're going to need to get the Ether price of Ethereum. So let's use the fetch function to do an HTML call. And now we need the API of CoinGecko. So it's this one API. This is the free API, CoinGecko. The endpoint we want is simple / price, and after we define the ID that the coin that we're interested in. So here what we want is native asset.coingecko ID. So no matter what, no matter the asset that you send, you will always pay the transaction fee in the native asset. For example, let's say you are sending USDT, but you will not pay the transaction fee in USDT. If you're on Ethereum, you will pay in Ether. So that's a native asset. Let's say now you are on Polygon, so another blockchain, and you are also using sending USDT. Well, it doesn't matter because the native asset in this case is not USDT. This is Matic. So the native asset will be Matic, etc. Okay, and then we also need to pass the other parameters. So we need to pass the VS currency. So that's going to be US dollar, and we also need to specify our API key. Okay, so let me do this here. This is going to be process .inf.next public coin gecko API key. All right. So now we need to extract the JSON object from that. So this is how you do it. Right. And now let's calculate the transaction cost in USD. So transaction cost in ETH time. And so now let me see. Okay, so ETH price. But is price, let's see the shape of the object in the documentation of CoinGecko here. So it's gonna have an inner key that is the CoinGecko ID we defined before, and then USD. Okay, so we need to target this. So let me see, native asset dot CoinGecko ID. All right, dot USD. And now we're gonna have a little problem because so this thing here is going to be an integer, but this price is not gonna be an integer because it's going to give you the decimal fraction. It's gonna be maybe 2,600 something times 89. So we want to transform this to an integer, and for that we need a scaling factor. So we are going to multiply this by a number and then going to divide this after. Okay, so let's so for our scale factor, let's do 100 because it's going to be enough. We're just going to have two decimal. Then let's define adjusted ETH price. So this is going to be this thing in time scale factor, and now we want to make sure that every time we're gonna have two decimal. Okay, so in order to do that we do two fixed 2. Okay, so now we have two decimal maximum, and when you do this, actually you're not even guaranteed to get an integer sometime. So for example, problem I noticed, let's say I have the price here, let's say this price point, I don't know, 55. Okay, so you multiply it by 100, so then you get rid of the decimal part. But then sometimes JavaScript does some weird thing where it's gonna add you some decimal like this. Okay, so that's why we want to transform this into an integer. Okay, like this, and now now from this integer we will transform to a big. Actually, I'm not sure if I can do a big int directly. I'm not sure if the pass int step is necessary. Anyway, big int adjusted is price, and now we need to divide it by the scaling factor. All right, so let me see what we have in the chat a little bit. So people are talking about what? So Vlad is saying, so hell to the Foundry for now. Yeah, Foundry is where you have to be as a blockchain dev, okay? It's what you need to master. Truffle, no, it's discontinuous. Don't use Truffle. All right, how you guys doing? Are you still following? Are you still awake? Let me know if you are awake. Say something, give me an emoji, show me a reaction, anything. Okay, so we have our transaction cost here in US dollar, and we're going to save this in the state. Set transaction cost is, so transaction cost ETH, set transaction cost USD. All right, and we need to define this state, of course. So use state. Right, and at first it's undefined. This is gonna be in way, so we need to remember this. And then transaction cost USD. All right. Okay, so now we have our transaction cost, so we will be able to display it. But we're gonna create an helper function because the string to display is a little bit complicated. So transaction fee string. All right, and first we're gonna have a transaction cost USD, but the thing is, actually, we need to, so we want to format this and pass the 1000 comma separator, but we also want to we also want to transform from a way amount to a non-way amount, because here, okay, let's back up transaction cost USD. So here, let me see. The transaction cost in ETH here, this is actually expressed in way, not in ETH, okay? But here the price, it's expressed in whole unit of Ethereum, not way, okay? So actually this quantity here is going to be too big, so we need to take into consideration the number of decimal of the asset. So that's why here we need to format this. So format way amount, and you see that when you do a wallet, even though it seems simple, but when you get into the detail, it's very easy to get confused and put the wrong format. So it's a bit more complex than it looks like. And here the number of decimal, native asset dot decimals. Okay, and let's import for my way amount. So import format from sorry, we were here. Then here, this is going to be USD, and after, between parentheses, we're going to put the amount in Ethereum. So let me see. Format, weigh amount again, and this is going to be transaction cost ETH native asset decimals. Yeah, I know this is a bit, this line is a bit ugly, but it is what it is. Okay, get transaction fee string. And now we're gonna use this helper function here. So let's make sure that we have a transaction cost in ETH and a transaction cost in USD. And let's execute our helper function. And if that's not the case, here we're just going to put loading. All right, so let me see. Wow, it is working, no mistake. Great job, Julian. Okay, so here the transaction fee for this Ether transfer is 16 cents, which is equal to 0.0063 ETH. Okay. So, oh, by the way, I think it will be nice to put the ticker here. So I think let's improve our function here. Yeah, let's do native asset.ticker. It's gonna be slightly better. So now, oops. Yeah, now we can see the amount of ETH. Okay, so let's see on Etherscan if what I'm saying makes sense. So they have this gas tracker here. And they can tell you what is the price of different action. Okay, so here for swap is $6, so now it's not very expensive. So they don't give you the typical price of an Ether transfer, but we can estimate it a little bit. Okay, so average, this is its number of GUI. So we know that an Ether transfer is 21,000 gas. So if the gas price is this, GUI time, let me see. Time 10 power minus 9 if we want it in ETH. Okay. Why it is not? Okay, no. This is okay, so this is the amount of ETH that we need. Let me see first if this is coherent with what we have. 1, 2, 3, 4. 1, 2, 3. Well, okay, we are a little bit cheaper, but not completely off the mark. And time, what's the current price? Price of, okay, let's see on CoinMarketCap. 2066.2, so 2066.2. Okay, so 41 cents, and we are saying 16 cents. But okay, so we are cheaper, but it's not like completely crazy. So it seems like we are correct. So cool. Now we have estimated the transaction fee. So next we need to send this transfer. Okay. So let's do this. Let's send the transfer. So we're gonna create a button for that. So let's get at the very bottom and let's create a new button. On click. Okay, send, and now we're going to define this function. And it's possible that it's disabled, but we're gonna see this later. Let's click, okay, submit. So let's define this send function. All right. It's gonna have a try catch. Okay, so we're gonna define a state called sending so that we know that this is still sending. At the end, no matter if there is a mistake or not, we remove this state. Another state that we're going to have is transaction hash. So once we've sent a transaction and it has been mined, we're going to show the transaction hash to the user. And finally, we're going to have an error state if we have a problem with the transaction. All right, so back to our send function. So we're going to, actually we can copy some code from before here. So let's create a transaction request. And when we have it, let's send a transaction, wallet.send transaction. And now we're going to get a what's called a transaction response. And with this transaction response, now we're going to wait for this transaction to be mined, okay? And once we get this transaction receipt, now it means it was mined. It doesn't mean it was successful, okay? It can be mined and not successful. That is why we want to make sure that it was successful. So how can we know if it's successful? If the status is different of 1, it means there was a problem. So we throw an error, and so we're going to end up here in our catch block. Transaction failed. Okay. And then set transaction, sorry, and if it was successful, then we continue and we set the transaction hash. Okay, transaction receipt hash. Okay, and with this we can show a link to the blockchain explorer. Okay, and if there was an error, basically what we're gonna do set the error to true, and after we're going to display all of these things. Okay, so okay, here I'm just gonna cheat a little bit because this part is not the most interesting. It's just like some messages, some information messages, but I'm going to explain what I do. Okay, so I've just added those 3 lines. So the first line here, line 126, if we are sending a transaction, we're gonna display this informational message that say just sending. If we have successfully sent a transaction, we're gonna see transaction hash, and here transfer successful with a link. Actually, we need to import this from Next.js. We also need to create this function get transaction URL with a link to the transaction hash. And finally, if there is an error, we're going to say that there was an error. Okay, so 2 things to do: create import link and create this function here. So create import the link first. This one is easy. So import link from next link. Oops, here's a slash. And next, we need to create this function. Actually, let's group the helper together here. Okay, so get transaction URL, and this one's going to take a hash as input, and after it's going to return, so chain.blockchain explorer. This is in the configuration that I defined. Then the hash. All right, and that's it. So now we should be ready to do a test to complete a transfer. So we have 10,000 ETH per account. So let's try to send, let's say, 1,000 ETH to this account. Okay, so it's going to be visible. So send. Okay, why is that? Oh, okay, wait a second. I have a little problem with submit here. So it's ugly. I don't want something ugly. Let's make it better. So here it's primary, and I want some space on the right. All right, so now it's better. Okay, 1,000 ETH. Okay, so let's click on submit. Now sending. And oops, the transfer failed. So why did it fail? Let me see the console. Receipt. Okay. This is my fault. So I think the transaction actually worked. It was just a problem on the JavaScript side. So just some typo here. Okay. Now let's inspect the output of Envo, our local blockchain. So we see that something happened here. If we, okay, transaction, gas used, and we cannot see here if that was successful or not. We can just see that there was a transaction. But what we can do is let's start a new terminal, and we can use the cast tool. So that is installed when you install Foundry. Okay, so that's a tool to interact with the blockchain of Foundry. So cast, it has different command. One of them is balance. That's for the Ethereum balance, and you just give it the you just give it the address that you want. So for example, let's pick the address that sent the Ether. And now, okay, we can see that we only have 9,000 Ether. Okay. And how about the recipient address? So originally it had 10,000, so now it should have 11,000. Let's replace this address by the new one. And yes, we have 11,000 ether. So the transaction actually worked. And here actually, if we try another transaction, let's just say 1 ether. Now this time we shouldn't see any error message. Sending, and yes, transfer successful. So in this case, it's not showing you, if you click here, it's not going to take you to any blockchain explorer, because there is no public blockchain explorer for a local blockchain. It makes sense. But if we had done a transfer on mainnet, it would have sent you to Etherscan. Okay, so yeah, finally it is working. Okay, so we can do basic ether transfer, and now let's tackle the token. So for that, first we need to show the we need to show the token balance on the home component page.js. So let's go back here. This is where we render the HTML. Transfer amount. Okay, let me see. Send. Transfer. Let me see where I am. Okay, this is just below logo. At this place, we're going to show the token. Okay, so class name, style, tokens. And so let's define some style for our token. Tokens. So for the background color, okay, let me copy all of this because this is going to be very similar. So background color is the same, border radius is the same, padding, and then some margin bottom. All right. What else do we need? For each token, so we're gonna have several tokens. We want some padding as well. And let's put some separator between the different tokens. All right, and finally the last token, we actually don't want any separator for the last token. So and let me see, border bottom none. Okay, so now we have our styling done. So let's go back to page.js, and we are going to define, so we need a state that has all the token assets. So to create this state, what we need to do here is we create another state that we call token assets set token assets. And we can define it here, initial token assets. Okay, and so we are going to iterate through all the assets we have, and we're going to filter. How we're gonna filter? We're gonna filter on the chain ID. Okay, so asset here, and let me see. And what we want is that the chain ID is equal to, so we should match on the chain ID, okay? But that's not enough because we also want to remove the native asset, okay? Because it's just the token here. And so second condition, the asset ID needs to be different sorry, here it's initial native asset dot ID. So yeah, we don't want a native asset, okay? And now we can iterate through these token assets, okay? So let's scroll down. Let me see here, token assets. And for each token, what we're going to do is we're going to print, we're going to show all the different information about this token. So here, let's for the key, let's give it the token ID. So that's React want this this prop here. Otherwise, it's going to complain when it render a collection. Let me see. Here, the class name is going to be token that we already defined. And now we're going to render the logo of the asset. Okay, so we can pass it the token. Then we can render the token name, okay? Then we can, okay, so actually we can give it here, let me see. We can give it a long string, so token name. Then after that, we're gonna have the token balance, okay? So so actually this field has not been populated yet, so we'll need to do some work in order to populate it. And only if we have some, let me see. So if we have some token balance, if it has been loaded, we're going to format it token balance. Okay. And what else? And finally, we need the ticker. So token.ticker. Okay. Okay, so let's see in the front end what we have already with this. Okay, interesting. So now we can see we have a tether and DAI stablecoin because this is defined in our configuration file. So now we need to populate the balance field. Okay, so let's go back here. And to populate this, actually, we're going to go to the use effect hook that we define here, where we get the balance. Okay, so let's do something a little bit different now. So we're going to group calls together, okay, because we need to get balance, but also need some other call to get the token balance. So let's define an array. All right. And inside, how are we going to populate this array? So first, let's get a token contract. This is an object that can communicate with the token on the blockchain. So we need the address. We also need the ABIs. Okay, so the ABI, this is a JSON interface that explains how you can interact with a smart contract. And I've already defined this ABI here. So this is very easy to define. You just need the function signature of the smart contract that you want to interact with. So here in the ERC20 token, we have more function than this, but we're only going to need those one. And here we have the function signature, and how we can get them. Well, ERC20 standard. So here you have the standard of the ERC20 on the website of Ethereum. And you can basically copy the function signature from here. You don't have to copy all of them, just the one that you need, and you put them in your ABI. Okay, and after, with this ABI, we can create this contract object to interact with the blockchain. Then the wallet, so that we can send transaction. So we need this contract object from Ethers. So let's import it. Where do I have Ethers here? Okay. Okay, let's go down. I have a token contract. Then here what we're gonna return is token contract dot balance of wallet address. Okay, so we're gonna build an array with a different promise, okay, where we call balance of, but we haven't sent the call yet. Okay, this is just prepared, stored in this array, ready for use. And now in this array, we're gonna push another promise. So provider get balance. So here. And now let's actually execute all this promise. So this is how we do it. Promise all and pass the calls. And it's how we can parallelize all those HTTP calls. So instead of waiting one after the other, we just do all of them at the same time. And now how to get the native balance. So we know that the native balance is the last element of the result array. Okay, so we just need to pop it from this array like this. And for the token balances, so we're gonna iterate through this array. And what we're gonna do is, so let's add the balance key to each token object. All right. And then we're going to create a new state here. So first state native asset. So we already have a native asset object. So we're just gonna add a new element to it, a new field, sorry. Native balance, okay. So, okay, and after that, set token assets. Oh, sorry, here should be token assets. All right, actually set balance, we don't need it anymore. We will remove it. So see set balance, let's remove it. And let's see where we used it, because where did we use balance? I don't think, did we actually use it somewhere? Okay, here, so we have native asset.balance, native asset.balance. Okay, so let's see if it is working. We have an error. So, okay, page 43, we have a problem. Let's see what it is. Page 43. Why? Token assets. Let me see. Cannot access token assets before initialization. Let me see. Token assets. Why that is the case? I don't understand. Okay, no, I think it's because, okay, I think I have an idea. Yeah. Okay, I see. Maybe here should be new token assets. Okay, so we still have a problem. Could not decode. Okay, so now I know what is the problem. So those two assets, actually, they don't exist on the blockchain yet. So we're going to create them because we use our local development blockchain. So I created a new a new folder for our blockchain project. For that, I use Forge init. So that's to start a new Foundry project. This is the smart contract framework that we use. And blockchain, this is the name of the folder. And no Git. So when you are in a Next.js project, you're going to have a Git folder. But Forge by default is going to initialize another Git folder, and it's going to complain because he doesn't want to create a nested Git folder. So with no Git, you're going to resolve this problem. And it's going to create this this blockchain folder here. Okay, so this blockchain folder is where is the Foundry framework, and in SRC, this is where you have your smart contracts. So, you know, the smart contract, these are the small program on the blockchain, and they are used to represent ERC20 tokens. So here I've already created a file called token.sol, and I'm going to create a token here. So we are going to use a framework called OpenZeppelin for that. So that is a popular framework for creating ERC20 token. And to install OpenZeppelin with Foundry, you can use something called soldir. Okay, so yeah, soldir. And here you tap OpenZeppelin contracts. That's the one we want. And so first you need to install the soldir package manager, and after you will be able to run this command. So you go in your blockchain folder, soldir install OpenZeppelin. So I've already run it on my side, and now I can import. Now I can import OpenZeppelin like this. So import OpenZeppelin contracts 5.0.2 token ERC20 ERC20.sol. Okay, and after we're going to inherit from ERC20, and just like that we have an ERC20 token. This is very simple. we still need to define a constructor, which is called when the token is deployed for the first time. It's going to take a few arguments. So the name of the token, the ticker of the token, the initial balance of the token, and finally the amount of decimals. Okay, and after we call the constructor of ERC20 that we inherited from OpenZeppelin, and we forward two arguments, the name and the ticker. And inside the constructor, we need to do two things. First, call the mint function. So that is provided by ERC20.sol. And first we pass so we pass MHD sender, which is the address of the sender of the address that deploy the token. Okay, so that's going to be our address basically, and the initial balance of token that will be minted to is to this address. And finally the decimals. So because each token can have a different number of decimals, usually it's 18, but it doesn't have to be. And uint8 private here decimals. Okay. And after we're going to overwrite the decimal function of OpenZeppelin. Okay, so public view override, so it returns uint8. All right, so now we have our basic token that is created. So we need to create a deployment script next. So here, this is the boilerplate code for a script in Foundry. And so let's define first two token, USDT, and the DAI token, right? So as a first function, I think that one is compulsory, but you don't have to have anything in it. And after we have run, start broadcast, VM stop broadcast, and everything that if you do any deployment on chain, it needs to be between these two lines. So first USDT, okay, new token. So the name is Tether and the ticker is USDT. And then the balance is going to be 1000 token times the number of decimals. So that's 10 power 6. Sorry, this is the initial balance. And then the number of decimal, this is 6. So here, the exponent here is the same as the number of decimal, okay? And same thing for DAI. Okay, so DAI stable coin. And now it's going to be 18. Okay. All right. So now our script is working. I've also defined a makefile that allow you to easily run command in Foundry. Okay, so I'm going to explain. So first we have the main command here is deploy that allow you to execute the script we've just run. So forge script, then the path to the script. Then broadcast is otherwise it just does a simulation, but we want to do the real thing. Then we specify the URL to our node, which is this one. And finally, the private key that we use for deployment, which is the private key of the first address, but it could be any address really. All right, so now let's run this script. So make deploy. All right, so a little problem in my scripts. It's fine. Let's well, what's the issue here? Token line 13. Okay. Fair enough. Let's try again. Okay, it's compiling. On-chain execution is complete. Okay, so we see two transactions. First contract is this one, so that's going to be USDT, and the second one is this one, that's going to be DAI. So now let's update our configuration file. Okay, so first tethers, it's not going to be this address anymore. Let's update it. And this one for DAI, it's going to be this one. Okay. So now let's see what we have in the front end. Okay, amazing. So now this is working. You see, 1,000 USDT, 1,000 DAI. So yeah, everything is working now. It's freaking amazing. So next, let me update here the form to make sure it can work with any asset. Let's do some cleanup here. We don't need everything. We don't need the logo anymore. This one, I don't think we need it anymore. We don't need this. We don't need this. So let me see in the form what happened. If we handle change, what happened here in handle change. So okay, so yeah, here it's not just native asset that we have now, but we also need to take into consideration the token. So that is the only change we need to do. Native asset, and the second thing is, let's destructure here. Let's add token assets. Okay, and that should be enough. So let's see if it's working. So for example, here, if I remove this, okay, it means this is not a correct asset. Transfer to and transfer amount, and also send are frozen. Not correct asset. Okay, ETH is a correct one. How about DAI? DAI is a correct one. How about Tether? USDT. USDT is a correct one. How about if I add E? No, that doesn't work. Okay, so this is working. So now we can see the token balance. Everything is working, both for just reading the balance. This is working for Ether, but also for ERC20 token. And now we need to make the transfer work also for ERC20 token. So for that, we're gonna need to revisit the transfer component. First of all, we need to change the, let me reduce this a little bit. We need to revisit the way we calculate the transfer fee, because now we just know how to calculate the transfer fee for simple Ether transfer, but now we have two cases to take into consideration: simple Ether transfer and ERC20 token. All right, so let's refactor our code. So let's define the estimate gas variable. And let's differentiate two cases. If this is if transfer dot asset dot, there's no address, it means this is a native token. Okay, and why? Because here, the way I configure my assets here, I just put address to the ERC20 token. But I could have added also, if I wanted, we could have done something like this, like address and then 0x and then here the 0 address. So we can also filter like this. Okay, but here, let's keep it simple. So they don't have a native address, don't have an address. Okay, so if they don't have an address, then basically what we're gonna do is we estimate the gas cost, but this time we're not going to do it that way. Oops. this time we don't execute this function right away. We just define it. We just configure this function, and this is going to be stored in this variable. So native asset else otherwise it's an ERC20 token. And in this case, we need to define a contract, a token object that can connect to the smart contract. So actually, let's copy paste something from page.js. Just give me 1 second. Yeah, right here. This is what we want. So let's define a token contract. Let's get contract from ethers. Where do we have ethers here? Yeah. So we have the token. Let me see. No, it's not token address. It's transfer. Let me see. Transfer address. Transfer dot asset dot address. The ABI, this is still the correct one, the wallet. I don't think we have imported blockchain. Let's do it. All right. All right, you guys in the chat, anybody still following? No, it's not .json. Sorry, it's .json. Okay. Then we have our token. Now let's execute the transfer function. This is the function that is used for token transfer. And now we're gonna use something called estimate gas. So if you're actually calling this function, basically you call it like this, okay, and you give the different parameter. But if you want to estimate the gas, you do estimate gas, okay? And be careful because now we are using Ether's v6, but if you're using Ether v5, estimate gas is before the function that you are calling. But in v6, this is after. It's quite tricky. Okay, so transfer.to, that's the recipient of the transfer. Then what about the amount? Okay, so we cannot put transfer.amount because that's the whole amount, but we need the amount in a way. So now we need a function called pass unit from ethers. Okay, and you need the transfer amount and the number of decimals. So transfer.decimals. And let's see, pass unit. Yeah, we already have it. Okay, great. Just semicolon. Okay, and now we have our estimate gas function. Okay, so now we're gonna do our different HTTP call at the same time. So promise.all. So first of all, estimate gas, okay? Then provider get fee data, right? And finally fetch this one here. All right, and let's get everything in an array. So first we have the gas cost, then the fee data, then ETH price row. All right. We're gonna do some cleanup. So let me see. This one we don't need it anymore. All right, so with this should work. Let me see. Send, and now we have an error. So probably there is some little problem. Cannot resolve blockchain.js. Okay, so transfer set line 7. Blockchain.json. It doesn't have the right version. Let's reload. Let's click on send. Object is okay. So transfer line 32. We have an error. So let me see. So promise.all. Promise.all is not happy. Okay. Missing the await keyword. Classic. classic. Forgetting the await keyword. Okay, and now it's working. Amazing. So transaction fee $13 for an ES20 transfer, and we can see the amount in ETH. So what about if we oh no, sorry, that was for ETH. So now what about for DAI? So it should be a little bit more expensive. Yeah, so it's more expensive now, 32 cents, whereas before it was 13 cents for a simple Ether transfer. So 32 cents for a transfer of what is this? Is hey, you know what? I feel like we're missing an asset. I feel like we should have an asset that show a field that show the asset. Okay, let me see. Is it the way I did it before? Oh yeah. We are missing this field, the asset field, because that's very important. So you know what? Let's do this. Let's do this asset field. So this is just above transaction fee. Let's call this asset. Transfer asset ticker. All right, so now let's click on send. And now we can see the asset DAI. Okay, so 32 cents to send a DAI, and how about to send a USDT? And to send USDT is not happy. Maybe we have the wrong. Let me see. Why do maybe we have the wrong address? Maybe we have the wrong address. Let me see. Blockchain.json. So USDT 0x9f. And what about what we have in our log? Let's check it again. So the first execution, contract address 0x9 finished by 6E0. And what about in our script? So in our script, the first one was tether, okay? And the second one was DAI. First one tether, second one DAI. I don't know what's wrong with USDT. But anyway, let's ignore this for now. All right, so the last thing we need to do is the actual transfer for ERC20. So let's revisit the page, the send function. Okay, so here let's define a transaction object. If this is a native asset, native asset, otherwise it's not a native asset, otherwise it's ERC20 token. Here let's shift this above. Okay, we build our transaction, and the transaction object is going to be this, but we don't put the await keyword here. We just define a function, but we actually don't trigger, we don't send the transaction right away. Otherwise, let's get oh, sorry. I think here, okay. I think here I made a mistake. It's not transfer dot decimals, but it should be transfer dot asset dot decimal. So it's why it wasn't working with tether. Okay, we'll try again. Anyway, so now we define so now we're going to do the transfer for the token. Okay, so contract transfer asset address, this is correct. And now we don't need to estimate the gas. Okay, we just need to create the transaction object. So token transfer, let's remove estimate gas, but the rest is going to be the same. Okay, and now await transaction now, and the rest is gonna be the same. Okay, so let's reload. Let's do for example USDT, and let's transfer 500 USDT. Okay, so transfer for 500 USDT. All right, let's click on submit sending, and suspense successful. So let's verify this. We can verify it easily with cast. Okay, so we can do cast balance, and we can do ERC20 and the address of the contract. So let me see, what's the address of the contract? This is Tether, this one, the first one. Okay, so the address of the contract, and after that the address, the actual address that you want to check. So here we did a transfer to this address, the second one. Okay, so, and it should have 500 Tether. And yes, 500 Tether, it is working. Woohoo! We made it. Amazing, guys. So now you know how to do a full wallet, fully functional. Okay, so you can see the balance of Ether, the balance of ERC20 token, and you can also do the transfer for those two assets. And yeah, the wallet is pretty polished, so it would be pretty good on a portfolio. So where would you go from there? So you have different way to put this on your portfolio. So first of all, you could add more feature. For example, here, the way we switch of address and of network is not very flexible. We need to change this in the configuration file. So maybe you could have a drop down that make it more, make it better for user to switch between different network and addresses. You could have, you could try to reverse engineer MetaMask and basically try to copy some of the feature of MetaMask into this crypto wallet. But of course, you will never be as good as MetaMask, because MetaMask is it's a whole team. There are like dozens of software dev, very senior guy. They have dozens of $1 million of funding, so you can never match this. But you can just try to like pick and choose extract a few interesting features, and this is what we try to do today. What else could you do with this? What you could try, you could track NFT, for example. That could be interesting. You could add a built-in way to trade on Uniswap. This is also something that is on Metamask. You could work on the packaging of the app. So right now we have the private, this is a web app basically, and the private key lives on your computer, but this is not really, as if you are the only one to use it, this is completely fine. But if you want to make it available as a tool, it's not great. So you could try to package it either as a mobile app, either as a Chrome extension, or as a desktop app. And the most simple would probably be a desktop app. And yeah, and so if you do this, it would definitely look a little bit more serious than just a URL localhost 3000. All right. So is there any question about this project? No, I see that some people follow up to the end, so congrats, guys. Before we finish, quickly, if you are new here and you want to know how you can get started with your blockchain career, check out this free career guide. So hittheblocks.com/roadmap is going to tell you everything you need to know. So what you need to learn to become a professional blockchain developer and how to get your first job in the space. All right, I hope you guys enjoyed today's video. That was the longest stream we did for a while, maybe forever, like almost 3 hours. So congrats for following up to here. I hope you learned something useful today, and I will see you next week. Bye, everybody.